In this tutorial I will show how to use the ChildActorAnchor property of physics joints. I have two rigid bodies that I want to link with a revolute joint. And I have set the hard limit of the revolute joint to plus and minus 70 degrees. That means if I simulate it, the attached actor is allowed to rotate up to 70 degrees from the start position. Now what I would like to do is to actually still have this limit and this range in which the actor is allowed to move, but have it start in, for example, this orientation. So from this line here, it should be able to move minus 70 degrees up and plus 70 degrees down. However, that is not how it works. The engine will assume that the position of the actor as it is at the start of the simulation is the zero axis. So instead of using this position as 0, it now uses this position as 0, and therefore the actor will rotate up to 70 degrees from here and is also allowed to rotate 70 degrees into this direction. The way to fix this is to tell the joint what the default orientation is. And that is done by using the ChildActorAnchor property. The theory how this works is a bit complicated. I will just show how to actually do this. So the easiest way is to start with the start orientation. So you position the child actor in exactly the position how the default orientation is supposed to be. Then you select the joint, and over here you just create an empty child object. And now you have this object that's at the exact same position. You then detach this so that it becomes a global object. And now for convenience we will actually attach this to this one, so that if I move this actor around, this reference point moves along. Now I take the joint and I will select exactly this object that we just created as the anchor point. So since this anchor point is at the exact same position and rotation as the joint is, there's actually no change. This behaves exactly as it behaved before. However, now when I select this, now when I rotate this object, the joint has a reference point that tells it what the zero orientation was. And that means that it now knows that this line was the original zero orientation that I wanted to use, and therefore it allows it to rotate from this position 70 degrees over here and also 70 degrees over there. So now I can very easily position my child actor exactly how I want it to be in its start orientation. For the revolute joint, I can now switch, for example, to the soft limit and say that it should rotate towards the zero angle, which is this. And if I start this now, that means the child actor will immediately be pushed back towards the zero angle. This is even more important for other joint types. For the revolute joint, you can use it to for example, create a door that has certain limits, how far it can rotate, and then you can select whether the door should start in an open or in a closed state, and so on. For the distance joint, this is even more important. Here I have a distance joint that is located at this position, and I have a box that is attached to this joint. And the distance joint basically just says that the object can't move further away than this. Now, since the position of the joint relative to the actor that it is joined to specifies the starting conditions, that means that I had to move the box exactly onto the joint so that the box can only move these 2 meters away from this joint actor here. I couldn't have positioned the box over here because that means that now the box is allowed to move 2 meters away from this position. And that means it can actually fall to the floor. It's not the joint position that is the important thing, but the starting position of the box. And that is a problem, especially when I want to use a minimum distance for the distance joint, because now the joint will immediately push the object away because it is too close at startup. And that can make the object move throughout the scene very violently right at startup and maybe end up somewhere or have effects that I don't want. I would prefer it if I can actually just take the box and say that this is the start position in which I want it to already start out. And using the ChildActorAnchor property, I can actually do that. In this case, I just want the center of the box to be the point that is attached to this joint. So that means I can just use the box again as the anchor as well. So the child actor and the anchor are the same thing. For the anchor, I really just need any object because all that I care about, or all that the joint cares about, is the position. And now the distance joint actually uses the center of the box as the reference point, and that means I can have the box in any start location. And it behaves exactly as I would expect. I can also use this to attach a joint to a different position of the object. So for example, I could actually create an object over here and use this one as the reference point. And now the joint attaches to this corner of the box instead of the center. The same can be used at runtime to snap objects back to a joint. So if, for example, you use a procedural approach to create a joint and have it grab some object, then you might not want the starting position of the object to be the reference point, but instead you actually always want the center of the object to be the reference point that the joint attaches to. And by just filling out the ChildActorAnchor property of the joint, you can make sure that once the joint becomes active, it will snap the object back to the position where the joint is located.